This is Target 2C, Arithmetic Sequences. I'm more than halfway through the unit now, so we're going through this one quick. All right, some objectives. You will be able to find additional terms in a sequence. You will be able to find the desired term for a sequence given a rule. And finally, you will be able to determine if a number is part of a sequence. So let's start with some vocabulary. So an arithmetic sequence is a sequence or a list of numbers in which the difference between consecutive terms, the numbers that come one after the other, is constant. So some examples of that might be 5, 10, 15, 20, because if you notice, each one of these is a sequence, okay? We have them in a list, and the difference between each one is the same. It's going up by 5 every time. Okay, this is a pictorial representation of a sequence. So again, here we have 2, 5, 8, 11, and 14 chips and stacks. And we are increasing by 3 each time. And finally, even this would be a sequence because it follows a set pattern. All right, so some ways to find additional terms of a sequence. So you might be asked to find the next two terms of the sequence, and you've got 1, 4, 7, 10, and 13. So first thing you want to do is subtract the first number from the second to determine how the numbers are changing from one to the next. So if we take 4 minus 1, because we're subtracting the first one from the second, we are going to get 3. All right, so we've got we're adding 3 each time. And if we continue to do that, if this is truly an arithmetic sequence, all these numbers will be increasing by 3 each time. So 4 plus 3 is 7, which is true. 7 plus 3 is 10. 10 plus 3 is 13. All right, so, but we need to find the next two terms. So we apply that rate of change, that plus 3, to the last number in the sequence, and then we'll repeat. So 13 plus 3 is 16. And then we take that last, which is now the last term, so we'll take that 16 and add 3 again, which is 19. So 16 and 19 are your next two terms of the sequence. All right, so here's an example. Find the next two terms in the given sequence. So first, again, subtract the first number from the second. So 41 minus 46 is negative 5. So yes, you can have a negative number. Okay, next, we have to subtract 5 from the last term. Because if we look, we're going down by 5 each time. So we're subtracting 5. So next, we'll do 26 minus 5, which is 21. And we'll subtract 5 from 21 again, which will give us the next term, 16. So your answer is the next two terms are 21 and 16. Pretty easy stuff. Okay, so now let's say we're given a rule, okay, which you guys should know now is like a function, and you have to find the desired term for a sequence. So you'll be asked, so find a sub 15 for the rule a sub n equals 5 plus, and then you've got n minus 1 in parentheses, times negative 2. So first things first, you take your equation, and if you look, we have a sub n, and then you have an n here. These two are actually the same number, okay? It doesn't mean that this number would be whatever n is, but we're saying, this is a way of saying the 15th number, like in this case, the 15th number, and then you plug in the 15 there. So first, look the number of the term that is being solved for. So in this case, it's 15. So we're going to take that 15 and we're going to plug that in for n. So a sub 15, and what this means is the 15th term. So we're not actually doing anything with this. Okay, that it's not part of the equation, it's not part of anything you're doing. So kind of like with functions, we're only working on this side. Okay? So this is the only side that we're working on. Don't touch this. This stays exactly the way it is. All right, so let me get rid of that. So you're going to plug in that 15 and just solve. So we say that 15 minus 1, okay, is 14. So remember, we plugged in the 15. So it's 5 plus 15 minus 1. And then that's times negative 2. So 15 minus 1, that's how we got the 14. And then it's 14 times negative 2 because, again, remember your order of operations. We have to do the multiplication first. So we're going to get 5 plus negative 28, because 14 times negative 2 is negative 28. And then we just do 5 plus negative 28, and that gives us an answer of 23. Again, pretty straightforward. All you're doing is plugging it in and solving. All right, so another example. Find a sub 10. So find the 10th term is what that means for the rule. A sub n equals n minus 1 times negative 3 plus 7. So we're going to take that a sub n equals n minus 1 times negative 3 plus 7, and we're going to plug in 10. So anywhere we saw n, we now have 10 because of this. Okay? 10 minus 1 is 9, and 9 times negative 3, so that's 9, and then times that negative 3 equals negative 27. So that's how I got this right here. So negative 27 plus 7 is negative 20. So negative 20 would be your answer. All right, so another problem I see is determine if 36 would be included in this sequence, and we've got 4, 8, 12, 16, 20, ... That means the sequence continues. So what we're going to do is we're basically going to follow the same steps that we used to determine the next numbers in the sequence, and we're just going to keep repeating the steps until we either reach or pass the number they're asking about. So in this case, it's 36. All right, so we say, well, and if you reach it, like that exact number, it is part of the sequence. If you pass it, it is not part of the sequence. So our next numbers, because we have a difference of 4, because remember, you take the first term and you subtract it from the second term. So 8 minus 4 equals a positive 4, so we're adding 4 each time. Okay, so 24 is next, 28 is next, 32 is next. 32 plus 4 is 36. Get rid of that. So it is part of the sequence. So another example. So determine if the value of 32 would be included in the sequence. So what's the difference? 19 minus 16 is 3. So we're adding 3 each time. So 25 plus 3 is 28. 28 plus 3 is 31. 31 plus 3 is 34. So we passed the number now, which means what? It means that 32 is not included in the sequence. And that's it. Nice short video, nice easy stuff. Shouldn't be a problem for you guys.